We are Mike Meusel and Karl Schmetters from the University of Zurich, the Department of Business Administration, and our presentation will be on innovative teaching with Mathematica and our experience of using Mathematica in an empirical methods class for master students.
Yeah, I do the show and he's doing the brain, so he is the brains of the project. Good afternoon, thank you very much for coming. We are both at the University of Zurich in the Department of Business Administration. Last spring, our chairman asked us to develop a new course in statistics called Empirical Methods for Business Students. So these are master students in a business program. They are in the age somewhere between 21 and 25 with little computer knowledge. And they had complained about the old statistics course. They never saw any data, but they saw lots of math, definitions, theorems, proofs. And so they were sick of this old style of teaching, and we thought we needed to change something. And we can't continue this way because this is the way the students describe the class. And so Mike and I decided, okay, what are we going to do? So we looked at I just had this discussion with Ryan. We looked at lots of different software packages, and to the big surprise of everyone in Zurich, we picked Mathematica instead of these other household names. The reason why we picked Mathematica was the graphical interface, the CDFs. We both are Mathematica nerds, and in our research we use Mathematica. And so we decided we want to continue with Mathematica despite its price tag, and see whether we can teach a modern empirical method statistics class with Mathematica. And so one ambition is, of course, you all have heard about the big new buzzword, big data, data analytics, and that's sort of our vision. Somehow that's where we want to go, down the road that we actually, everyone talks about it, nobody knows exactly what it is, but we want to be able to handle huge data sets and analyze them in Mathematica. Then, of course, our fear was maybe instead of sleeping on books, the students then get bored out of their mind in front of the computer and fall asleep, or they have nervous breakdowns. And perhaps the nerds in the end will be happy. So that was our goal. And so that's where we wanted to go. And right from the beginning, we threw them into ice-cold water after teaching them just a little bit of Mathematica. They had to do a homework project in Teams. And we're going to show you a first clip of sort of what I had envisioned, and which happened much faster than what we had thought. And here's a team that had to decide that between Christmas and New Year's you want to go skiing in Switzerland outside Zurich. Where would you go?
We had to look for places near Zurich in order to be able to celebrate White Christmas this year. We found here 365 cities which with this population. Was the green points, they indicate that in these cities there no snow, and the white points they had snow, and the thicker the white point is, the more how do you say, snow deepness, the more snow there is.
So the students were very quickly able to use Wolfram Alpha, download in this case snow data or precipitation in the Alps in a radius of 50 or 100 kilometers outside Zurich, and then pick your favorite vacation spot. So while that's early on, they cried about the amount of work they had done, they really liked it afterwards. So now, first, now let's look at the big picture. The historical shortcomings that we had identified is that historically, students, even in business and economics, take statistics classes, but only learn about the theory of statistics. They actually never see a data set. So we wanted a more holistic approach between theory, application, data, software, interpretation. They complained that textbook problems are typically too boring, outdated, unrealistic, and so we wanted real cases and real data. In my prior life, I had written some Harvard business cases on statistics, on data. We use them. The students complained a bit because they're all US data. Right now we try to Swissify and Europeify the course. So if anyone has a cool data set, send us an email. Yeah, we need you. This is a common complaint that the students may remember the central limit theorem, but they're actually on the job, they don't know how to handle data. Or they know, oh, now I need to run a regression, but I have no idea what that is on the software and how to do this. And so we wanted to emphasize a lot of learning by doing. Actually, here's the data, now load it into Mathematica and solve it. Then we wanted to be very interactive, both with the students, helping them, and so that they also come to us and teach us where they are struggling with Mathematica and with handling big data sets, in order to sort of motivate the students and make them more creative. And finally, we all have done this, of course. You learn to the test, to ace the test. And so what we didn't want that to happen. We had lots of homeworks along the way, and in particular, final exam that was very similar to what we had done in class. And so the whole class, the assignments and the final exam were very focused on actual projects. Here's sort of a general roadmap, perhaps a more boring part. Everything is done in Mathematica. We have here a list of many, many lectures with an outline, learning objective, whether it was confidence intervals, hypothesis test, various features, examples, then calculated. And whenever we showed them calculation, there was also then a spot on the actual code the students had to learn. Now, my favorite part is this part of the course. We have these tutorials where we made a big mistake that early on, this first homework was a team assignment, and so there were some people just coasting. Yeah, you just have your best friend who is a math nerd in the class who carries the team. We will change this. Next year, we already learned first tutorials, and there will be individual assignments where you're all by yourself. So we force the students to learn Mathematica ASAP. We had assignments, cases, we had then these presentations. Every assignment had case presentations. And then sort of even at the end, and that's my favorite part because it saved us a lot of headaches, and Mike will explain this, the final exam, entirely done in Mathematica, and it wasn't just multiple choice. And so this was sort of the heart of what we did in Mathematica, and now I hand over to Mike, who will show you the nitty-gritty. Thank you.
Hello. Here you can see what we have developed in the last year. Unfortunately, I cannot show you all the things, but I will try to pick up a few. Let's start with the slideshow tool. So our idea was to improve the usability, not only for the students, but also for us. So we said, we want to easily create slideshows in Mathematica, and I will do this here. So let's call it the 1-minute lecture, and give it first lecture. Then we can section. So I'm just using some of the features we used in the slide, just to show you how that works. Okay, we also can just include Mathematica Code, for example, a nice plot like this. Evaluate it, and it's not like okay, let's try it again. Yes, and so this is so these are the slides, and if you deploy it and if you show it to students, maybe you don't want to show the code. So we say this is input, and this is a graph. And now, since we're running out of time, next lecture, second be interactive, and then demonstration. Again, I just want to use some of the demonstrations already available with the demonstrations projects. Statistics, let's take this one, download the author code. Okay, so then we can get the code from the demonstration. Just copy and paste into our slides. Again, we don't want to see the code later, so we say it's input and we say that's output. And now we click on deploy, call it 1 minute lecture. Save this, and here we are. So this is how the lectures, the slides look now. You see here the lecture title, and you see here an overview of the lectures. Then you click here, and you see no code, and here is the interactive demonstration. And it also comes with a contact button, so students can directly send emails to us asking us something. And it comes with a print button because it's kind of tricky to print slideshows. Okay, so this is just that you get an idea how we are creating those slideshows. And now I want to show you how this looked like. So here, this was the actual course, and yeah, we don't have time to look for all of those. We have here some learning objectives, and here a demonstration. Here some tools we did on your own, and then we are very case-oriented, so this is a case environment, so you have motivation, a solution, and at the end there's always a step-by-step solution where the code is explained in detail. Okay, so the next thing I want to show you is the exam, so just going to the end of the lecture, and this was really challenging for us because 150 students, and was basically a 2.5-man show. So yeah, we don't wanted to grade them on our own, but we also wanted to the students to apply their skills in Mathematica and not just doing a paper and pencil test. So this is how the exam looks like, and as you can see here, it's individualized for each student has their own exam file, and it also has some data attached. So the students were asked to really calculate, perform regressions, fit models, and so on in the exam. And I can show you this. So you need to evaluate initialization cells first, and this gets green. And then you have to enter your matriculation number. In this case, it's this number. And then you see, good luck. And as you click on it, then the exam starts. You can see here is a timer. So after 90 minutes, the exam shuts down, saves, and yeah, game over then. We had some multiple choice questions, but this is maybe not so interesting. The main part of the exam was on the actual calculation questions, and we always asked for 3 steps. The first step was, given that question, students should choose one of the approaches we suggested. And at the second point, you can see this here in this blue field. There's a variable called exam data, and if we evaluate it, it's there. So you can just calculate whatever you want with it. And so that was also very important. We graded all that which was in this red framed box. And afterwards, they had to interpret their calculations. And so this was the general setup. So the questions are like this. And what maybe is so interesting is all the files were individualized. So as you can see in this question, there are some numbers, $50 million and 4,100 theaters. And the students were asked to estimate and to make a prediction. And all these numbers are functions of their matriculation numbers. So if 150 people are sitting next to each other, then cheating is very easy if you don't, if you only need to make some, only need to click some buttons. So this really prevents cheating, because as you can see here in the interpretations, we have things like up to 60, 60 to 80, and all of these answers were actually right for some students. So and of course we randomized the multiple choice question and like this. So really try to prevent cheating. And then we asked for a feedback because this was our first time we run this exam, so we wanted to know how it's working. And then this exam files were returned to us, and we took them and get all the numbers out of it. And unfortunately I cannot say more to that. We have to go to the next point now, which is the reporting. So we also did all our reportings at Mathematica files. So here you see this for the final grades, and again people had to enter their matriculation numbers. And then you see again her name, and she did quite well in the exam. And here you can see how you compare to others, but you don't see the names. And then people could see their performance in assignments, and then the final grade. In Switzerland, 6.0 is the best, by the way. So yeah, this is our reporting, and here are the results from the exam feedback, and I think that's quite okay for us. Difficulty should not be too easy, and overall is also okay, but time was maybe a little bit too less. So for next time, we reduce the number of questions and hope to match the needs or the abilities of students. And then here also some more information how the grading was done and so on. And we had a lot of FAQs. So at the end, grading this exam took us 4 minutes, and there were no errors because it was made by computers rather than people. And so this is quite an efficient way to handle such big courses and exams. So, yeah.
Before I get to the am I on? Can you hear me? Yes? Okay. Before I go to the feedback, Mike is very proud of that curve where every student sees where he or she is in the class. That gives you headaches. Yeah, he loves it. For me, there were headaches because suddenly students realized where they were in the distribution. Yeah, and then they whine much more. In particular, I'm 5 points below the mean in the assignments. So, but he loves it. Yeah? Feedback, of course, this was a huge learning experience for us. And so we got mixed results, and we show you both sides of the distribution. Some people got, after some initial struggle, got really enthusiastic because Mathematica, as we all know, is a fun tool, a great tool, and they could solve practical problems. So I think the general premise of the course continues to be right, and we will continue this way. A criticism then was that Mathematica is hardly used in industry. Some students from their internships came back and said, my company uses R or SPSS. They don't know Mathematica. And so this is, we need just sort of more applications, and I already encouraged Ryan to sell more copies into industry so that our students then see the applications outside the universities. At the beginning they were very frustrated about these time-consuming homeworks. We all have done this. You have somewhere an error in the code and it takes you an hour to debug it. So they were sort of early on, we were also struggling, and we will address this with more tutorials next year, but the students eventually all got it. We didn't have any total breakdowns in the final exam, which I was afraid of, and then they usually come with a lawyer, and you don't want to go there. This encourages us, so we will do this again. Again, similar way, some people really struggled, and that just means we need to force them to have an individual assignment early on, and so that they are forced to study really hard in the first few weeks when they're still sort of, their mind is on vacation. So they take a new look at statistics, and thanks to Mathematica and the many practical applications we have. Right now we are developing, and so we need more examples, we need more European data, more Swiss data, and we're looking for partners who help us to develop statistical applications, big data, business analytics in Mathematica. So thank you very much for attending our talk.